Hey everyone, today we're gonna start with a fresh topic, Docker. However, it's not very new concept of Docker, but Docker is a containerization solution since very long time. Everyone is using it, but it's a kind of new approach or new way of telling that what Docker is. This is basically for total beginners. All right, so let's get started. Before we understand and get into the Docker, we need to know that why we need a Docker or what is the concept of containerization, right? Docker is a software, but it becomes a kind of another name of containerization because Docker was a company who introduced the containerization in Linux. So one thing to know is that Docker or containerization is pretty much for the Linux-based platform. So a basic Linux understanding is a primary key for anyone who is trying to start with Docker, right? So for Docker, if we talk about why the containerization is required, so I'll take you to little bit of the uh, time before where we were understanding or working on things like virtualization and physical servers. So I'll open up here a whiteboard and I'll tell you that if let's say given an example, you have one web server, you have mentioned something you have mentioned in Java Spring Boot, you have developed a small API application, or even if you have a kind of HTML, CSS, and JavaScript based static website also. You want to run that as on any kind of server. So what is the primary challenge for any user or any organization is that they need a server. Now if anybody who needs a server, if you go ahead and see that server, in which form the server comes in. Here is I'm trying to illustrate that how the server. So as an example, your server is coming with this much of capacity, 32 CPU and then 256 gig of RAM. Nowadays the server are even giant, more than this capacity servers are coming in. But assume that you have 32 core CPU and 256 GB of RAM. One server you have. You got it. You purchase this server and then now you have a plan to run your static website on this server. The problem with this one is that this is actually a very giant machine with request to what is your web server demanding. Your web server, if you're running on this physical server, right? This is a physical machine, okay? This is a physical machine. And if you're running your web application, let's say I'm saying that this is your web app, okay? This is your web app. If you want to run this web app on top of this physical server, your web app has a requirement of only one CPU, that is 2 CPU is a time, and so it is possible, quite possible that your web server is taking even less than that, less than one CPU. Okay, so what is the primary problem here? That all your resources are getting waste. Okay, but anyways, let's not talk about the resources and its wastage uh, for now. Let's park them for later. But still, if you see, there is one problem. Problem is that resiliency. You are running your web application on a physical server which is not resilient. It doesn't have any redundancy. You don't have any another physical server, right? So in any circumstances, if this physical server is losing the connectivity, this physical server is, let's say, not healthy, any physical hardware or something, some damage or something has happened with this server, your entire application is completely down. This is a problem. This was a problem which uh, started coming up. Then people started thinking about the solution, and then a concept came in that was that let's build something similar, a second person. I'm giving you one small analogy. You will all be able to understand that. If let's say think like web application is a workload for a manager, for an team. You have a project team, okay, and in your project team you have, let's say, one task you are getting from your client. You in your team you have engineers, you have managers, you have team leads, etc., scrum masters and others. in your case, let's say you are the only one engineer who is working, right? So it's the physical server is like you as an engineer, you are working only one person. And web application is like a workload here for the server, real time. Let's say in analogy, the workload is your task, your incident tickets, etc., which you are resolving. At any given point in time, if you, let's say, fall in sick, you're not able to uh, resume the work for any day, the workload or whichever incident or anything will come up for that particular day, nobody is there to handle. So we have lack on redundancy. So what managers or team leaders will do, they will hire another person, so that if this person is on sick, then another person can handle the workloads. This is the situation with the servers also. If this server is down, this server can take care of the workload which is running over here. But in this situation, both the servers has to be of same configuration, and both the server has to be running with the same set of configuration of software and configuration of hardware, etc. And at any given point in time, one server will be acting like a active server, another server will be behaving like a passive server. But the question is that there should be some mechanism or methodology using which these two servers should be able to talk to each other, and they should be able to understand if another server is down or not, right? So this concept we called it as cluster. This is when you have a same set of people working on same set of services, right, to achieve the single goal, single value. It's like cluster, right? So what happens is that here we got a kind of cluster, and this cluster, what we called it as, this cluster we started saying that this is a kind of active passive cluster. Fair enough. So we have a cluster now, but the mechanism was, if you technically see that who should be able to talk to each other, then it's in this case the operating system is a primary software which you are installing on top of physical server. So it's a kind of, we call it as what, OS based clustering. OS based clustering. Now in this OS based clustering, what happens is your operating system would have some sort of software. Let's say in Linux, if you say pacemaker is one of the example, right? The pacemaker application, which is a cluster application, that will be deployed over here and over here in this server as well. Now with the configuration of pacemaker, pacemaker will consistently keep checking both to each other. Hey, you're alive? Hey, how are you? You're alive? So in any situation, both will be keep checking, but they mutually both know that my workload is running where? My workload is running over here in this case. Okay. So what happens is when any point in time this server is going down, right? If this server is going down, then this server with help of the pacemaker will get to know that hey, another server is down. So what it will do is that the web application, this will become active, and which was passive earlier, it will become active. Now the only problem which you see is that if you have a user, okay, for example, if you have a user over here who has to access the application, the web application, the user has to then in this case start checking. User needs a single set of IP address, right? User will not switch, but we know that the server has IP addresses. So what happens is that we called it as that you have one virtual IP. Okay, so here this clustering software has a feature of creating a virtual IP. This virtual IP would always be associated with whichever server is active. So let's say for example, here is the user. User will be connecting to the virtual IP. Now the virtual IP is, let's say, was associated earlier with this server. Then if this server becomes passive and this become active, then VIP will be associated automatically over here with this server. All right. So this is a plain simple example why we wanted kind of redundancy. But we understand that the problem still is there. We have a massive amount of resource wastage. To eliminate this resource wastage would not be a good if we can somehow segregate these physical resources in multiple virtual resources. Here the solution comes in as virtualization. Now what is a virtualization? Let's try to understand over here. Virtualization is also kind of same thing, right? So if I have a physical server with this much of capacity, what I will do is I will try to create, earlier I had operating system. Now what I'll do is I'll try to install a software here. Earlier we had OS, Linux, Windows or anything. On top of that, we were deploying our applications, right? Single set of application, multiple set of application. On top of this, we were running, right? Okay. So what we do is now, if you see in operating system, whenever the application needs a kind of any CPU for a computing or memory for a storage, operating system was taking from the physical layer and it was giving to the application for their requirement. So it was like my operating system layer was responsible for a handshake, right? From these application. If the application required, hey, I need a glass of water, right? Then OS was that it was taking a water from here and it was serving to them. So it's same like for CPU requirement and memory requirement. We call it as resource scheduling, which is operating system kernel's responsibility. So that's how the resource scheduling works, right? So it means that you need one layer between application and this. That is operating system software. We what we do with the virtualization comes in picture. We replace this OS and we say that it's a hypervisor software. Now, what is the function of the hypervisor software? That instead of operating system, we used to deploy hypervisor software. Now, hypervisor software has the same kind of ability that it could get the computing and memory capacity from the physical layer and it could pass to the virtual layer. Now this virtual layer, instead of application, what we started creating is we started creating something we called it as virtual machine. Okay, so this was VM1, this became VM2, this became VM3. So what happens is that out of these 32 CPU and 256 GB of RAM, we can assign some of the capacity to this VM, some of the capacity to this VM virtually. And how this is possible? Because we have a hypervisor software, that is why it is possible. Otherwise it could not, right? We have now a software which is handling this kind of allocation, etc. Right? Now the virtual machine, if you have, then on top of this virtual machine, what you can do is you can start running your applications inside the virtual machine. And now you have one more ability that virtually you can install any kind of application. Let's say if you want to run Windows or you want to run Linux, it's up to you. You can run Windows also, you can run Linux also. If you had a physical server only, then you could run only single operating system. Now, when you have this kind of architecture, what you do is that now you can run your application, web app, right? You can run now your web application and your web application can run here. Another web application or any other application can run on this machine and this machine also. So what you see is that earlier you had a physical server, right, where you could run on top of operating system one application. Now you can run multiple application segregated in their own environment. You see here what the applications are getting their own environment. Okay, remember this, that applications are getting own environment. I'll tell you the significance of this when I will start talking about the Docker and containerization. So here what is required here, that a virtual machine start booting. Now you can deploy set of libraries, Linux libraries, set of binaries, etc. over here for this virtual machine. And your whichever is required for this web application to run, to function, all the environment you can set up over here in this virtual machine, right, with all the setup commands. And then you are making sure that your web application is running. Same thing is happening over here with this virtual machine also, same thing is here. right? Irrespective of which operating system and which application you are using, you will do a configuration, and this will be like an environment. This VM is entirely an environment. Earlier also, in case of physical machine also, it was kind of environment, but you had segregation, no segregation, right? Now you have virtual machine. Virtually, with the help of software, you can manage this environment. Earlier, with a physical machine, you cannot manage, or you could not manage any point in time any environment which was required to run, right? You could set up, but you could not manage. But here you have the functionality. All these virtual machines are also in a form of software. It means these would be kind of physical, no, rather virtual machines. Virtual, it means virtual. What is virtual in our computer world? Virtuals are like files, right, which you cannot touch, you cannot feel. Softwares are files, right? What is the software? Are files. So virtual machine also is coming as a file. The hard disk is a file. The computer configuration, the virtual machine configuration, how much CPU and memory are allocated, those are also file, right? That's how this phenomena comes in picture. Okay, we call it as virtualization, wherein anybody could segregate simply the physical resources into multiple virtual resources. Still, the problem here is that we don't have a redundancy, right? We don't have redundancy. If this physical, even it is worst, if this physical server goes down, all your virtual machine and inside those virtual machine, whichever applications are running, those all will be down. So what we started thinking is that can't we take another same set of virtual physical server and we can make it cluster. But then the idea started coming in that if we make this cluster, we don't want to make them as active passive. Now think about it very carefully. If we make active passive, it means one will always be unusable. It means that everything is down and it would be very complicated. But if you want to make both of them active, it means that who will be taking care of which one. Another point is that when you have a virtualization and you want to make a cluster, your cluster should be scalable. Scalable as in tomorrow if I want, I could add another node also. So this is active, this is active, this is active. So as much as capacity I want, I can keep increasing my capacity by adding multiple physical servers. So overall what I want is that I want to create a kind of cluster so that I can get the aggregated capacity of each physical machine, and then I can create virtual capacity out of that. And at the same time, we can achieve the high availability or redundancy as well. When this started coming in, this function, we had to have a kind of manager, or there should be some third person who should be enough capable of handling all these virtual machines, who should have inventory of all these machines, etc. Right? So hypervisor, I'm trying to give one example also. Let's say VMware ESXi. Okay, so VMware hypervisor, we have ESXi. Very good. There may be multiple, let's say, uh, Red Hat virtual Vertujo and Citrix Zen server and Hyper-V, Microsoft Hyper-V. There are many hypervisor softwares which you can use. Linux KVM. So ESXi, I'm giving one of the examples. So ESXi was one of the example. Now think like that. Why we need a kind of controller, manager, or someone over here, that the person who would be, let's say, creating the machines, the person, okay, who is creating, earlier who used to create the machine, he has to log in into individual machine. But if you have a cluster of, let's say, I'm talking about 1 to 3 machines, but in enterprise we can have 50 or 100. So how this person will get to know that where I have to create my virtual machine? Because virtual machine, the next virtual machine should be created at that place where the capacities are available, right? So all of these things, this person would not be able to understand. That's the reason there we have another software we introduced. This software had a responsibility, and I'm telling you in a very easy way here. I'm going to tell you that what this software meaning is, right? And this will help us in understanding the Kubernetes concept as well. So let's keep hearing this. So this software, right, which we brought up and put it at somewhere different place, not inside this machine. Now this is kind of manager. I'm giving you an analogy again for a teamwork. Let's say You had two engineers, right? The machines are, let's say, these physical boxes are engineers. And here you have, let's say, your team leader, your manager, your scrum master, right? You have two person working in team. Now you wanted more capacity. It means that, let's say, you had these two machines where you could create six virtual machines you have created. Now you have to create seventh virtual machine. What will happen? You need a next node to pull into this cluster ecosystem, right? In the same way, if you have two engineers in a team, your manager sense that we are getting more incidents, more workloads, we need another engineers into the team. So what he will do is that he will uh, onboard another engineer. So when another engineer comes in, the another engineer will also start reporting to that manager. That's how here it is. This software acts like one of the component inside this software would be the manager, right? Manager. So manager is who gets register all the cluster nodes with itself and who keeps track that how many nodes I have healthy, who is going on leave and all of it, right? And then there should be a team leader who should be able to assign the work, right, to create the work, etc. So and who should be making sure that who is running how many of loads, etc. That we called it as controller. Controller is another component which is part of in this software itself, right? This software we called it as what? Orchestration. Now this manager controller. So controller creates virtual machine. Now this person has to talk to this software only, and he has to submit all the virtual machine creation, start, stop, requirement, everything, right, to here in this machine, right? It means that think like this is your client. Your client should not be speaking to you straight away, right? Your client should be talking to your manager. So when there is a manager, it means that there should be some interface here. Now that interface we call it as what? This is a software, we call it as orchestration software. The component which is responsible of getting, we called it as API. That is the application programming interface, GUI or CLI. So this user, this person will be sending the information that, hey, I need to create another virtual machine, the seventh virtual machine, right? And that virtual machine information he will put up with the API. Now API needs a database where API can insert all these requirements which this person has given, right? So the another concept or the component comes here is database. Now what is the database here? That in database the API whichever information this person wants, that let's say this person wants this machine has to be powered off. So this person will interact here and he will put the status of this virtual machine in database as powered off. Now the controller will keep listening or keep reading from the tables of this database for the status, and the moment is controller sends reads from the database, this person has given the instruction into database, right, from the API. Controller reads that information and controller simply execute that information, right, over here. So this VM virtual will be powered off. At the same point in time, if the this person is giving an information that, hey, I need this virtual machine, one new virtual machine, and it has to be of this much of CPU, this much of memory and everything, then this person will give the information API. Again the information gets inserted into the database table. So database table controller start reading it. Oh, I have a new virtual machine information. So controller will try to create it, but controller needs information. First information, it will read from the manager's table that how many nodes we have, right? So controller will simply ask to one of the component who is having all the information that how many nodes we have, how many nodes are running with how much of workloads, which node has a sufficient capacity available, right? That component we call it as scheduler. So you will have another component, we call it as scheduler. Now this scheduler will tell controller that, hey, you can go ahead and third virtual machine, you can create a third physical server node, you can create a virtual machine from the to there, right? Scheduler will tell this to controller. Now the controller will start executing. Now you may be surprised that if the controller is, let's say, this is orchestration software and there we have one, two, three, four, five components always available, right? The entirely this is a software suite where all these components would be, and this entirely the software we call it as orchestration software. In this case this will be, if the workload type is virtual machine, it means that this orchestration is mainly saying or talking that how many It's managing the virtual machine related workload only. This will be VM orchestration. Same kind of design or architecture you can get with some other clusters also. So we will call them a different set of cluster. Let's say if this would be, instead of virtual machine, the containers, then the set of operating system, the set of orchestration software, or the orchestration software will call that out as container orchestration software. So here is a virtual machine orchestration software where these are the components. Now I'll tell you the name of this software because I have given you a hypervisor name as ESXi. So now I'll give you the name of this orchestration software. We called it as VMware vCenter. This is a software. Now if you give some load on your mind, you will get to know that in a VMware vCenter you need database, right? PostgreSQL if you are using appliances, or Microsoft SQL Server if you are installing it on a Windows server. That's how. And manager, controller, and scheduler and APIs are part of that software itself. Okay. Now you may be surprised that hey, controller cannot go ahead and do SSH or do RDP or something and create virtual machine interactively. No, right? It cannot do. So what is controller and what it is doing? So guys, every node will have one agent of this. When you are registering this new node with this orchestration software, one agent will start running here. That agent is with which controller is talking. Okay, so that agent we call it as VPXA in this case. Okay, I'll not give the name, but I'll give agent. Fine. So we will have, let's say, one agent running over here, one agent running over here, one agent running over here. So your controller is talking to this agent. Now agent has all the information, all the connects, the system call, the interfaces, all the interfaces over there. What happens is controller will give this information reading from the database to the agent that hey, stop that server, stop that VM. Agent will stop that VM, right? So agent simply follows. Agents do what? Two things. First thing, agent is keep sending the health information of this node right over here to vCenter or orchestration software. An agent takes the workload of what controller is saying to me, that information, right? And then agent execute it over here because our controller cannot directly talk, right? It should have a small interface. So the agent is getting connected. Now in case of VMware, the agent name is VPXA, VPXA, VPXA. If the VPXA service, if you stop, then the hypervisor ESXi will become unhealthy and it will not be in the cluster anymore. So that's how this entire phenomena of the orchestration software works. Now why I talk about all of these things and what is the relation of all of these things with the Docker is you see that we minimize somehow maximum resource wastage here. But if you see one more situation, still the virtual machine you have assigned, let's say one CPU. I'm giving a very small example, let's say one CPU. But your virtual, you have a web server only. That web server could run even with the zero point 0.05 CPU itself because CPU is a time. We can go with the 0.05% of the CPU, right? It could run. It could run with a 1 GB of RAM only. Simple static website. It could run. For that to run entire virtual machine of a Linux, where Linux itself is taking CPU etc. because Linux will get load itself with lots of. Now let's try to draw another box and we'll now talk about a virtual machine here. Okay, so if you have a virtual machine, the virtual machine will have many components, right? How many components you will have in a virtual machine? You may have components like, okay, so in a virtual machine you may have a component like OS, kernel, run labels, right? Basic libraries, we call it as OS libraries, etc. Binaries, services. These are not required for you. Actually, these are not required for you, not at all. But still, these are coming along with the virtual machine because with the virtual machine you are deploying an operating system. with that operating system, it needs OS, it needs kernel, it needs run level, it needs basic libraries and binaries, etc. Then only that virtual machine will be started. Another problem, that virtual machine when it starts, right? Virtual machine starts, it loads certain set of services. When it goes down, then also it is keep stopping services in a chronological order. This is a problem because it is taking an overhead of the time. It's taking a time to start your main component, which is your web server, let's say Nginx in this case. So if I try to describe the components, right, OS components, in OS actually everything is directory and files. So you have /etc, you have /bin, you have /root, you have /opt, you have slash. There are many slash and everything starts with the slash. You know why? Because slash is your root. It's like C drive of something, right? So here we'll have lib64, etc., etc. Overall, this is your directories only. Now you think, if I talk about one of the web server, okay, your web server, let's say given an example as Nginx. You want to run Nginx web server to host your static websites. Now you are installing Nginx packages. Now Nginx packages will have what? Nginx packages will have something like files to get into Nginx. Inside Nginx, it will have some files like let's say nginx.conf, right? And there would be some supportive libraries also which will go over here. There will be some binaries also which will go under this directory, right? Let's say giving a very rough example of, let's say, so you actually need only this. You don't need rest of the other things, right? But if you see the operating system, its environment, the web server configurations, environment, everything is what? Everything is directory structure. Now think about it. If there is a mechanism using which you could archive all of these Nginx related file folders, etc. only, okay, with some set of basic OS libraries, etc., which you need. And if you could archive it or put in a different folder, archive and put in a different folder. For example, I give you a small example which will make this more clear. Guys, let's say this Nginx you need uh, to run two Nginx. Can you install two Nginx? One is a different version, another is a different version. You will say no. Why? Because if you install Nginx once, this is a file, let's say, it gets created at this location. If you try to install another one, it will say that, hey, Nginx already exists. Why? Because this is the same location, the another Nginx package also has the same file. Now you know that in one directory you cannot have duplicate files. So that is where when you try to install another application of the same application, right, on a same operating system, it gets failed by giving that application already installed because it validate, reviews and checks, and it finds all the files and directories are available there. This is where, what if you could install Nginx in a separate directory? For example, I'm giving you another example. Let's say in var lib docker and then vm1 container 1. Inside this you may have etc nginx nginx.conf, right? This will be, then container 1 will be your base. So your base dir is equals to this one, right? Container 1. Now for another Nginx installation, you may have another base directory, container 2. And if I say that this way you try to install, you will say that yes, we can install. Those who know that how we install application using source code, not with RPM or DEV binary, they would be understanding that yes, when we are running make install and giving the path, right, prefix, we can somehow run the same thing, right? That's where the idea of containerization came in. We know that operating system is still available. Operating system, libraries, binaries available. Only the set of Nginx related libraries and binaries, right? We wanted. And we could run them in a separate container or folder. Then we can run multiple Nginx. It means that in a same virtual machine, we can run multiple web server. We can host multiple websites. So this way, if a one virtual machine gets assigned with one single CPU and let's say three web servers, three websites we are running, right? Separate, individual in their own isolated environment. This is really very good, right? Why? Because we can now utilize the full capacity and they all three can share the same set of CPUs and memory, etc. Okay, so this is where the idea started coming in. So if I say that what is container, container is actually the directory structure, libraries and binaries, and this directory structure is consisting not only the application related libraries binaries but OS environment, minimal environment libraries binaries also. Okay, this is we called it as container. So you can think like container is a process, is a process. Now what is a process? Process is a single executable command, right? So think like process, it means that container is a kind of single executable command, one executable command. Okay, so that command will work with a Linux kernel. So you need one single Linux kernel, one operating system that should be able to run multiple containers. Okay, it means that multiple runtime environments where you can run your isolated process with their isolated own set of requirement into the environments, etc. Right? That we call it as container. And but you know that in IT, to do anything, we need software. Like in my previous example, when I was talking about this diagram, where I said that here I removed operating system, instead of that I put hypervisor. Hypervisor is a software. Without hypervisor, it could not be possible that you could create virtual machine, right? Because this is a function, this is a feature. Any feature into the computer comes in with a software. The software has a logic of those features or execution. That is how it is possible. For example, if I tell you that I'm not giving you Windows, uh, Microsoft Office, and then you have only Notepad, and I'm telling you that hey, create me a PowerPoint PPT. Is it possible? No. Why? Because you need a set of software. You need a software which is primarily built for that operation, right? That's where the containerization also. So here, if we talk about what is the containerization or why we need it, right? So if you go ahead here, you will get to know that the containerization means that process. So that process and this directory structure, etc., is possible only when we have a software who would be able to run all of these things. So this kind of software we call it as what? CRI, and this is we call it as container runtime interface. We can call it as a container software also. So Docker is a name of that software. So what does this mean? In your normal Linux machine, if you have Docker installed, then you can run containers. Now I'll try to take you to the page where we can try to understand more practically in a hands-on way. So here I have one virtual machine. If you see, I don't have a much of processes running in, nothing installed. It's a freshly installed Ubuntu 22.04. I don't have anything running over here. So what I have a plan is that I will try to run this machine, and inside this machine I will try to create a software. Sorry, I will try to run Docker software here for you. I will tell you that how to install. At the same time, I have one web page here. Uh, just give me a time. I'm pulling that page. Okay, so here is one of the GitHub page. I'll give this in the description box where you can get this. So if you go here, I have already documented, right, how to set up the Docker in Ubuntu. Okay, so in Ubuntu, if you click on this, then you will get to know that yes, you can SSH into your Linux box. You can run this command straight away. This is just when you don't have a curl install, then for that, right? So let's try to run straight this command. So I'm going here. I'm trying to run this command. What this command does, it does the curl to get.docker.com, which will print you shell script for the Docker container installation. Then that output it takes passing with the sudo sh. So in a shell script, in a sh terminal or sh session, the execution steps coming from get.docker.com will be executed one by one, and you see that my Docker is getting installed. This has get installed now. So earlier I had no Docker command, but now you see I have Docker command. I can run Docker hyphen hyphen version, and it will give me something like which Docker version I am using here, right? So I've installed Docker here, but you see that I actually uh, did the SSH with user root. So now I'll tell you one small problem also which usually people are facing. So let's say I'm running Docker command from here, Docker version. You see that Docker version is running, but few commands, right? And we will understand all the commands of Docker, managing Docker network, volumes, storage, containers, images, everything going forward. So if I run Docker PS, right, then you see that Vijay user is able to execute this Docker PS command. How? If let's say it is giving that Docker, the user is not able to connect to, right? If I run here, let's say doc ID Vijay, you see that Vijay become already part of this Docker group, right? So if let's say user Vijay is not part of the Docker group, and then still you want to uh, then what will happen? So let's try to see. Then you will get to know that you are not able to run the Docker commands as a normal standard user. So the process is here. Just add Docker as secondary group with the user, log out, log in back, and when you run Docker PS, this will start running in. If you want to uninstall Docker Community Edition, you can run these commands and your Docker will be cleaned up. That's where I have installed my first Docker. When you have Docker, then the example which I was giving, that I said that if you have Docker, you can run multiple Nginx, but how you will run? You can run like this, Docker run -d Nginx. What it will do is that Docker command will try to run the Nginx container, but question is it doesn't have that container image available. So what it does, it tried to download that Nginx image, container image from somewhere. Now, what is that somewhere? That somewhere is a place, we call it as container registry. It is a kind of marketplace where all the different container, all the different software providers are uploading their container images. It's a kind of marketplace. And from there, we all can pull them. So if you see here, it says line by line that unable to find Nginx latest, and then it started pulling from library Nginx, but actually it got the machine from where it got the machine from Docker Registry Hub. We will talk about the Docker registry and its nature and how you can set up your own registry, etc. later on. So Docker PS, if I run again, I see that there is one Docker container running. But I said that we can run multiple. So if I'm running Docker run -d Nginx again, this time the image was locally available. So that is why it created a container and it prints me the container ID. You see 00195 here, 3117 ACC. If I run Docker PS again, you see that there are two containers running from the same Nginx image. right? This is where how we can run multiple containers. But I told you that containers are a directory structure. It means that there should be a basic directory created. So how the distinctions are happening between the directory, how the containers of the same images are getting uh, deployed. Let's see here. So I'm changing my prompt as root, and I'm going here in var lib docker, and there if I run ls, I see that there is a folder called it as container. So I'm going into container, and if I run ls again, I see that we have two directory, 00A95, 00A95, and then another one when I run another container, 3117, 3117. So what happens is that whenever you create a container, the image getting downloaded, image is what I told you, that image is a compressed archive of the container directory structure along with the libraries, binaries, etc. So what happens is the image in compressed or format or archive format always available on a marketplace. When you run docker run command, the image gets downloaded locally, and when you run a container, then that image gets decompressed at this location. The name of, if I run, let's say, docker run -d nginx again, it creates another container. If I run docker ps, we will get to know that we have three containers. But at the same time, if I do ls, we see that we got another one, e6, right here, the new one which has got created. So this is how the containers are getting created by us, and we all can understand that containers are like this. We all can try to get into this, but it's not like you will find the correct directory structure, etc. No, it's not like that. But for every container, you will find the host name, the host, mounts, resolve.conf, and some other things, right? But these are actually, you cannot straight away understand or read these things. You need to take help from docker commands. So everything, all these management we do from docker command. So let's say docker, if I run docker images, this command will tell me that how many local images we have. We have nginx image available. Okay, how many containers we are running? Docker ps, this is a container, three containers we are running. All right, so for today it was like we are now able to explain that what container is. We are able to understand and explain that why we need containerization, why we need virtualization, why we shifted our gears from physical machine to virtual machine, and then from virtual machine to nowadays container, right? And what container is and how it works. Going forward, we will try to understand more in containerization, and we will do a practice of multiple container docker commands.